Good morning, children. Yesterday I have told that today we will discuss about numericals based on Nernst equation, delta R G naught, the standard Gibbs free energy change, and equilibrium constant Kc. In first lecture I have told this chapter is equally has weightage for theory and numerical. So look this numerical. Represent the cell in which the following reaction takes place. The cell reaction has been given Mg solid plus 2Ag plus this concentration has been given 0.0001 gives Mg2 plus concentration is 0.1030 m plus 2Ag solid. Calculate its E cell, EMF for the cell, if E naught cell is equal to this. So first, we have to represent this cell reaction. This is cell reaction. And you have to represent the cell reaction into cell representation. So you can write cell representation. Cell representation. Mind it, I have told anode half shell, then bridge, then cathode half shell. In my first lecture I have told representation of cell, that is anode half shell, this is bridge, and this is cathode half shell. Now on the basis of this numerical, please check on which oxidation takes place and on which reduction takes place. Now see, here it is magnesium solid, it is converted to Mg2 plus. Naturally, oxidation of magnesium takes place. And Ag plus is converted to Ag solid, means reduction takes place. So, the cell representation is like this, Mg solid slash Mg2 plus. I have told at that time, if concentration is not known, then you have to write aqueous only. But here concentration is known. So in bracket, you should mention the concentration of this Mg2 plus. Now bridge. Now check reduction. Ag plus converted to Ag. It means Ag plus concentration you have to mention, and in any problem if concentration has not given, no need to write concentration, only aqueous. Here 2 is not mentioned here. See, in cell reaction the coefficient is 2 before Ag plus. In cell reaction, in cell representation, 2 is not mentioned. This is cell representation. Now, calculation of E cell. Calculation of E cell. So, according to Nernst equation, first we have to write the Nernst equation of this numerical. So, E cell is equal to E naught cell minus 0.0591 by n log Mg2 plus Ag solid divided Mg solid and Ag plus square. Coefficient is square. Now, we know what is the value of, you should bother about n. So from Mg to Mg2 plus there is loss of 2 electrons, and Ag plus to Ag gain of 1 electron. So if you write the anode reaction, cathode reaction and overall cell reaction for cancellation of electron, we found that the number of moles of electron will be 2. So here n will be 2. So E naught cell given, E naught cell is 3.17 minus 0.0591 divided 2 log. Concentration of Ag solid and Mg solid is considered as 1. So it will be this only Mg2 plus. What is concentration of Mg2 plus? 0.130 divided this 0.0001. You can write this as 10 to the power minus 4 whole square. For simplicity, I have converted this into this term, 10 to the power minus 4. Now, our E cell is equal to 3.17 minus 0.0591 by 2 log 0.130 into 10 to the power 8. You can write. For simplicity, you have to take one digit before the decimal. So we do E cell equals to 3.17 minus 0.0591 by 2 log 1.30 into 10 to the power 7. You can write this in the form of 1.30 into 10 to the power 7. Already we know log A into B is equal to what? Log A plus log B. And log A power B is equal to B log A. You are knowing it. So E cell is equal to 3.17 minus, you can solve it, 0.02 to the 4, this is 2 and 9, 5 approx. Write like this, log 1.30 plus 7 log 10. Correct? You know log 10 is equal to 1. So E cell is equal to 3.17 minus 0.0295 log 1.30. Now see the log table. What to do? In class 11 already you have read about log table, how you see the log. Now check the number of digit before the decimal. Before decimal it is 1 digit. So write 1 less, I mean 0 point. And see the log table 13 column number 0. First 2 digit you have to see the log. Third digit column number and fourth digit should be mean difference. So look here, this is 13. 13 and the column number is 0. So 0.1139. 1139. You can write 1139 plus 7. Log 10 is equal to 1. Can write log 10 is equal to 1. Or E cell is equal to 3.17 minus 0.0295 into 7.1139. 1139. Now for simplicity, for saving time, I am using this calculation, but for you this is not allowed. So 0.0295 into 7.1139. The value will be 0.209. Can write 0.21. approx 1209 it is coming. I have written this. So E cell equal to, turn right, just subtract it. This is 6 and this is 9. This is 2.96 volt. This is your answer. Okay. Now the next question is in text 3.6. The cell in which the following reaction occurs. Look the reaction. 2Fe3 plus aqueous plus 2I minus aqueous gives 2Fe2 plus aqueous plus I2 has E0 cell is equal to 0.236 volt at 298 Kelvin. Calculate delta R G0 and standard Gibbs free energy change and equilibrium constant. This is Kc. Already you know the formula. Delta R G0 is equal to minus NF E0 cell. Now the problem is what will be the value of N here. So to check that you have to write anode half reaction. Anode half reaction is what? Fe3 plus anode half reaction is I minus aqueous gives I2. Solve it. You can take. So there is loss of electron. So there is loss of 1. For balancing 2, you should write 2. There is loss of 2 electron. This is anode half reaction. Now cathode half reaction. Cathode half reaction. This will be Fe3 plus aqueous plus 1 electron gives Fe2 plus aqueous. Now, in first anode half reaction, there is a loss of 2 electron, and in cathode half reaction, there is gain of 1 electron. So, what will be the value of N? Actually, if you write the cell reaction, naturally this reaction should be multiplied by 2. Now, the value of electron in this cathode reaction will be 2 and this anode reaction will be 2 and both electrons will be cancelled out. Therefore, the value of N is equal to 2 here. In such problem, our main task is to search the value of N. Students, if one is asking such type of problem, then you have to think, sir, what is the value of N here? So N value is the vital problem. If N is correct, then everything will be correct. Now, delta R G0 is equal to minus ENF E0 cell. Minus NF E0 cell. So therefore, delta R G0 is equal to minus 2 F 96500 and this is 0.236. Therefore, delta R G0 is equal to, just I want to say 2 into 96500 into 0.236. So this is 45548. 45548. This is joule per mole. You can convert into kilojoule. Therefore, delta R G0 is equal to, this is minus 45.548 kilojoule per mole or minus 45.55 kilojoule per mole. This will be the answer. Now, calculation of Kc. Here we are having two formula for the calculation of Kc. One formula is by first method is, you see, E naught cell is equal to 0.0591 by n log Kc. Know this formula. It is my advice to adopt this formula, because during solving numerical you will do mistake in calculation of delta R G naught, and you are going to solve the value of Kc on the basis of delta R G naught. There may be chances for the error. So you have to use this formula. Now E naught cell value is what? 0.236 is equal to 0.0591 by n. N value is what? 2 log Kc. Therefore, log Kc is equal to what? Check. Just 2 into 0.236 divided 0.0591, or log Kc is equal to, just calculate. Mind it, you have to calculate by own. 2 into 0.236 divided 0.0591. This value will be 7.9864. Please focus here. I have taken 4 digits after the decimal. There is also some point why you are taking 4 digits for accuracy. Now therefore, Kc is equal to what? NT log 7.9864. Now, how you see the NT log? Please open your NT log and see. NT log is always seen after the decimal. NT log is always seen after the decimal. Don't bother about the digit before the decimal first. So, first 2 digit 0.98. Look the NT log 0.98. This is 0.98. And third digit is 6. 0.98 and this is 6. 6 digit is 97. 9683. So check 9683.98 and this is 9683, and the main difference is 4. Main difference is 4. This is 9. So add 9. What I have taken? Check. You have to see the NT log 0.98, first 2 digit. Column number is 6. That value is 9683, and the main difference is 4. That value is 9. You have to add it. So 12, this is 2, this is 9, this is 6, this is 9. So value is 9692. Now what we do here? According to my opinion, first you have to write the decimal after 1 digit only and into 10 to the power the value which is before the decimal. Yani this is 7. Your answer will be 9.692 into 10 to the power 7. This is value of Kc. Now, the second method for calculation of Kc. Second method. You can calculate second method to calculate Kc. Actually, according to my opinion, you have to use this method. This is most useful and doubtless method. But suppose you can use this, you can. So delta Rg naught is equal to minus 2.303 RT log Kc. This value you can use. So you can use delta G naught was what? Check, that value was minus 455,480. 4555 can check into 10 to the power 3. Just kilojoule I have converted into that. You can write this is equal to minus 2.303 8.314 into 298 log Kc. So you have to convert delta G naught into joule first. Why? Because the value of R is in joule per Kelvin per mole. Don't take this value in kilojoule. Or Kc is equal to, or log Kc is equal to, this minus will be cancelled out. So that will be 4.45.55 to 10 to the power 3 divided 2.303 into 8.314 into 298. Or log Kc is equal to 7.983. Just to calculate and you get the value log Kc. Now again, therefore Kc is equal to what? Anti-log 7.983. Just roughly I am going to check it. So Kc is equal to, again the same method, 0.983. This is 0.98 and 3. 96.3 9616. So this is 9616. 9616. Yes. So yes, is equal to what? Just I have taken only 3 digit has been taken after the decimal. So 0.98, the column number is 3, this is 9616. Put decimal after 1 digit and into 10 to the power 7. So this value is nearly same as the previous value. Just what is the difference between these two values? Although in normal side books this formula has been taken. But according to my opinion, you have to use the previous formula which I have used. Okay. Now, come to the next problem. See the question number in text question 3.4. Now, look the question. Calculate the potential of hydrogen electrode. Calculate the potential of hydrogen electrode in contact with a solution whose pH is equal to 10. So this is a very beautiful question, and there may be a little bit confusion among you. So how you are going to solve? Now first you have to write the reduction reaction on H plus. So H plus aqueous plus 1 electron, it is converted to half H2 gas. So according to Nernst equation, you can write EH plus slash H2 is equal to, actually PH2 power half you can write, and here the pressure is 1 bar. So you can write as this also, EH plus slash H2 is equal to E naught H plus slash H2 minus 0.0591 by N log PH2 power half divided H plus aqueous. This is the real format of the Nernst equation. In numerical, if pressure has been given, suppose the pressure of hydrogen is 2 or 3 or what, so you must use the partial pressure of the hydrogen. But here, in a standard condition, the pressure of hydrogen is 1. It is not given, so we assume it is 1. So this value will be 1. So that will be E naught H plus slash H2 minus 0.0591 by N log 1 by H plus aqueous. Now, we know that in class 11 we have read pH is equal to what? Minus log H plus aqueous. Therefore, pH is equal to, or you can write pH is equal to what? Log 1 by H plus aqueous. So put this value here. So the next format is what? EH plus slash H2 is equal to 0.00 volt. You can see this value from your electrochemical series. Yeah, it is standard, you should know it. Minus 0.0591 by N. N means 1. G1. Into pH. This is pH. Already pH is equal to log 1 by H plus. You know. So put this value. And in question, the pH value has been given as 10. So EH plus slash H2 is equal to minus 0.0591 into 10. So the value will be minus 0.591 volt, and that will be your answer. In previous class, I had given you assignment, homework, as all the NCERT problem. In test questions, already 2 questions have been solved here. In test question and NCERT exercises question. So, the today's homework is point 1. Solve 5 problems based on Nernst equation from your side book. Which side book you are having, there is no problem. Or you can search the numericals from any side book, and you can solve 5 problems based on Nernst equation. And second, solve 5 problems based on delta R G naught and Kc. This is also from your side book, because in previous lecture I have given assignment to you for solving all the numericals which are given in NCERT books. So today homework is this only. Now in next lecture we will explain the concept of conductivity, molar conductivity, and some formula based on that, numerical based on that, variation of conductivity with concentration, molar conductivity with concentration. Be ready for that. Thank you.